Welcome to Module 32 in this series of lectures on statistical process improvement and statistical quality assurance. This is the second part of our discussion of patterns on control charts that includes a discussion of so-called extra alarm rules that we'll get to at the end of this little talk. Another phenomenon that sometimes produces funny looking results on a control chart is the phenomenon of so-called mixtures. And mixtures are roughly the combination of two or more distinct patterns of variation, either in a plotted statistic or in an underlying distribution of individuals that goes into a plotted statistic that get put together in a single chart and make somewhat odd looking patterns that look other than as they should, where there's a completely random mechanism behind individuals that are being put into a plotted statistic. Here's one kind of mixture. This is a kind of mixture that produces large variation on a control chart. You might think of a situation where plotted values of some statistic look like the plotted values on the left, and basically there's a large part of those that are down at this level, but then there are a few of them that are up at this level. If one makes a histogram of the values that are plotted against time on the left, one gets this kind of a picture. And that distribution has two pieces. There's the main piece, and then there's a mixture of that main piece with that smaller piece that represents the unusual, occasional large values. These correspond to the values up here on top. That phenomenon says that I've got sort of two things going on there. This part of it is unusual, and if one could eliminate it or move that part down to the rest of that distribution, one could presumably improve process consistency. Sometimes people talk about that second piece is representing free plotted points. When observations on a chart sort of bunch up, they're at this level, and then they're at this level, and 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 basically they group together in time. One might describe that kind of a mixture as one that produces large variation and could be described by the word bunching or the word grouping. That kind of a pattern might be driven by rotation of operators or gauges or changes in raw material batches, that kind of thing. Again, the point is to not just to say, oh, that's a mixture pattern, but to think about what are causes that could lead to that. If those causes can be mitigated, one would hopefully get a more consistently behaving process, reducing variation, improving quality. Here's an interesting possibility that somewhat paradoxically can come about by the existence of a mixture. That's a picture where a plotted value is not ever getting out near the control limits. And at first thought that might sound lovely, but actually not so. That kind of a pattern can happen because one has just made an error in the computation of control limits. But another way that it can come about is through a kind of mixture known as stratification, in which a process has radically different components that are nevertheless highly consistent within those components, and somehow those get sampled in a systematic fashion and plugged into a plotted statistic. And in violation of the notion of rational subgrouping, where one wants to think of values that get plotted or get turned into a particular statistic at a particular time as coming from a single process, a physically stable process. Uh, if those get if they're radically different components, then paradoxically one can get uh, unexpectedly small variation. Think, for example, of a machine that has, say, 10 heads, one of which is completely bad and 9 of which are perfectly good. If one naively took one item made by each head at a time period and made what one thought was a p-chart, one would get consistently 1 out of 10, 1 out of 10 bad, 1 out of 10, 1 out of 10 non-conforming, 1 out of 10 non-conforming, 1 out of 10 non-conforming. One would have a p-chart that ran right down a center line at p of 0.1. What's going on there? Well, one has missed the fact that there are 10 different streams there, 10 different components of the data stream that are being sampled absolutely systematically. Those streams are all internally consistent. One of them always consistently bad, the other 9 always consistently good, and that causes sort of not enough variation on a control chart. So that's an instance where a mixture gets sampled in a systematic fashion and produces not enough variation on a control chart. So not enough variation on a control chart tells you that you made some kind of an error. You made an error of calculation of limits, or you're naively missing something about the data collection process. And the point is that one then is not reacting properly to process changes, and in fact won't see process changes because things are unnaturally stable, apparently unnaturally stable. Once you begin looking for patterns on control charts, the question arises as to exactly what ought to be considered to be a pattern. That's particularly important in organizations where multiple operators are going to make control charts. There has to be some standard agreement as to what a pattern is and what a pattern is not. And it's also the case that without some fairly rigid understanding of what constitutes a pattern, people tend to want to see patterns that are in actuality not at all unusual, and so there needs to be some kind of agreement. There are various sets of rules for declaring what a pattern is. Special checks, or quote-unquote extra alarm rules, extra beyond a rule that says as soon as you get a point outside the control limits, you have a reason to investigate. Most of those pattern, or most of those extra alarm rules, are phrased in terms of this kind of a picture, where if this is a center line and this is a 3 sigma upper control limit and this is a 3 sigma lower control limit, one divides the region above and below into 1 sigma region, a 2 sigma region above, a 1 sigma region below, a 2 sigma region below, and outside the 3 sigma region, and does things, say, like this. Here's a particular set of possible extra alarm rules. It's one that came out of a famous statistical quality control handbook that was published by Western Electric and later by AT&T. One might look on a control chart for any point that plots outside of 3 sigma limits. Look for any 2 out of 3 consecutive points that are outside of 2 sigma limits on a single side of center. Look for any 4 out of 5 consecutive points outside 1 sigma limits on a single side of center, or look for 8 consecutive points on one side of center. That is an arbitrary set of rules, but it's one that is well known, and you can see in that some attempt to provide operational definitions for what patterns are. It's not obvious whether this or some other set should be employed, but the motivation for making such sets is clear. And if you're going to use extra checks, then one needs to be consistent across people that are going to do the control charting.